two very important things here. So this is the same with f of theta. Y or f of theta mean the same thing. So for this function, I would like you to understand that f prime of theta is the derivative function, of course. And I want you to understand that the differential of f of x is a totally different thing. F of theta. Totally different things. This one will be y equals f prime of theta times d theta. If the function is theta, I have to have d theta. If the function has x, then I have to have dx. But this one is simply the derivative of the function. The differential of the function is the derivative, but multiplied by d theta, the differential of the variable, of the independent variable, but this one is just the derivative. And you can say, well, what's the big deal? It's a big deal because we're going to get to chapters 5, and you're going to see how big the deal is. Okay? The differential is one thing, the derivative is another. When I find a derivative, yes, I have to use the product rule. 2 theta times sine 2 theta and plus theta squared times cosine 2 theta times 2. One more time. Theta squared prime is 2 theta times sine 2 theta. And then theta squared plus the derivative of sine, which is cosine, times the derivative of the inner function, which is 2. So then I will rewrite it as 2 theta sine 2 theta, put the 2 in front, plus 2 theta squared cosine 2 theta. But this is not what I'm asked to find. I'm asked to find the differential. Okay then. So I will write y equals all this times d theta. So 2 theta sine 2 theta plus 2 theta squared cosine 2 theta times d theta. So please understand the difference between the derivative and the differential. Good. So we had... Exactly? I'm sorry. Go ahead. Sorry.
What exactly is d theta here?
It's the dx. The differential of x from here. So the only difference here is that I have theta and I have theta. So then this becomes theta and this becomes theta. It's a different variable. It doesn't matter what it is. It will be the same. The same formula.
Okay, so if we had to plug a number in, right, at some point, we just did this.
This is the differential. This is the differential, if you want. Yes, it's the differential of x, which is the minor change in x, dx, or d theta. If this is theta, then I have d theta, but this is x in our case. It's the minor change in x.
Okay, so let's say theta is pi over 6. What is d pi over 6?
Awesome. Very good. Let me say this. Awesome question. Very good. If theta equals pi over 6, d theta is tiny 0.01 or 0.002, which means this is your theta, which is pi over 6. So your d theta, I'm zooming in huge, your d theta is 0.01.
Right, okay.
In other words, this is the x for p, and this is the x for q at a distance of 0.01.
Right, okay. Thank you.
It's not very clear yet, but you will see in a moment how we use it in more examples. Okay. So we know how to determine the differential of a function. Now, let's also evaluate one. I don't know, let's say 21. In 21, we have y equals the square root of 3 plus x squared. They say x equals 1, and see dx is negative 0.1, tiny. It could be left or right of 1. It doesn't have to be to the right all the time, because the error can be in disadvantage, not always in advantage or plus, right? So we are asked to find, for this problem, we're asked to find a differential dy and evaluate it. So we picked 21. So now we know that dy will be 1 over 2, the square root of 3 plus x squared times 2x times dx. It's dy, not the derivative. So 1 over 2, the square root of 3 plus x squared times the inner function prime, which is 2x, times dx, because this is dy. Yes, I will simplify a little bit. A factor from the top and the factor from the denominator. And I have x dx over the square root of 3 plus x squared. So now, no problem. I'm asked to use x equals 1. And I'm asked to use dx as negative 0.1. No problem. So 1 times negative 0.1 will be negative 0.1 divided by 3 plus 1 is 4. The square root of 4 will be 2. So negative 0.1 over 2. Or negative 1 divided by 20. So what does this mean again? If a radius of 1 inch has an error of negative 0.1 inch, this function will have an error of negative 1 over 20, the function value. Okay, will have an error of negative 1 over 20. The function value of y will have an error of negative 1 over 20. What will be the exact? What will be the exact error? I have to calculate it. Delta y will be f of x plus delta x minus f of x. I don't know what the exact is, but it had better be very close. So x plus dx, they're the same. It's 0.9. So I have to find f of 0.9 minus f of 1, which I know is 2. So this will be the square root of 3 plus 0.9 squared minus 2. And that is the square root of 3 plus 0.9 squared. Close the parenthesis, go outside, subtract 2, and I get negative 0.048, and 1 divided by 20 is negative 0.05. I didn't have to do that with a calculator. Okay, so the approximate error in the function using the derivative is negative 0.05. The exact error in the function, not using the derivative, but just using algebra, is negative 0.048. So the error, of course, it will never be exact, has a minor error of 0.002. This is the approximation, and this is the exact. Any questions? Any questions? Okay, let's look at finally what I really wanted to. 31 through 36. This is our first applications of differentials. I created a discussion. I wanted to postpone it for a few minutes, so we don't have to worry about it right this moment, but I can get in to change the time so we can do it a little bit later, or tomorrow. I can change it because I can get in. Let me try one more time. So if you want to work on that, I don't even know if you can access it now. I have no idea, because I can't get in at all to make any changes. Oh, look at that. I think I can. So you would like to do it now. You want to You want to postpone it a little bit?
That's fine.
So you want me to change it or let you work on it? Yes, I know it's Microsoft, the crazy world of Microsoft. Yes, I know. So you want to work on it then?